Alright, let's talk about the stack. So what's the stack, you might ask? Well, let me just quickly open this up. So online whiteboard, I'll quickly just draw something explaining it. So the stack is one of the key concepts for something like this. So give me a second. Let's just let this open and draw. Alright, so think about the stack in assembly language like a stack of books, right? Let's say I have one book here and I have like two books here. Let's call this book A, and let's call this book B, and let's call this book C. Alright, now let's say I wanna read book B, right? How do I get to book B? Well, I'll first have to remove book C, so I take this out. Only then can I remove book B, right? So in the same way, a stack works in a similar way in assembly language. So you can stack values on top of each other. So you stack values on top of each other. So let's say I have the value A as 1, 2, 3, right? On top of, like, as a stack of values. Now let's say I want to access value A. Well, since A is at the bottom of the stack, I'll need to remove all of these elements to access element A. However, if I want to get element C, it's right at the top of the stack, so I have to just simply take this book out and nothing else. Now, let's say I want to add another value to the stack, right? To add another value, all I can do is add it to the top. I do D4. I can't insert a value into the middle. That just simply doesn't work. The only way to insert a value into the middle is somehow to remove all the values above it, insert the value, and then place the values back in. That's like the only way. However, if to insert it to the top, you simply just insert D4, you simply just add it to the top of the stack. Now, why am I talking about like what all of this? Well, assembly language requires, like all of modern processing, uses something called the stack. So the stack, so what's the difference between this and RAM, you might be asking? Well, RAM is sort of farther away from the CPU, so it takes a lot more time to interact from the CPU to RAM. So it takes a lot more time to interact between the CPU and the RAM. However, if you want really, 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 and I mean really, really fast, like storage, cache for storage, you can say, the CPU has like this cache basically called the stack, which is like this place for super high speed access to small memories where you store values such as this. Now, why might the stack be something like helpful while coding in assembly language? Well, let's say we have two values, right? Let's say we move racks, let's just call this A, comma 10. Now, let's say we need to add, and now let's say we move B, comma 20. Right, let's say we only have these two registers, right? We only have A and B on the computer. There's nothing else. Let's just say this for the example, right? So we move A, comma 10, move B, comma 20, and we add A, B. So this gives us 30, right? So now A equals 30. So register A is 30. But what happens if I want to get what was register A originally? Let's say I want to know what was A originally. Well, simply I can, in the middle, push A to the stack. So I push A to the stack. So now what happens to the stack is a new value enters the stack called, let's just say, which is 10, right? So now I push A onto the stack, so the value 10 enters the stack. Now I have add A comma B, and now A is equals 30. It's not equals to 10 anymore. But if I want to get A's original value back, I can pop it from the stack. So I do pop A. What pop means is it takes the last element on the stack and takes it out and returns it to the item. So it takes out the top element and puts it on the register A. So now A equals 10 again. Get it? So maybe like after adding a comma b, you can somehow print a, so however you do that. And then now you want to get a's old value back. So you pop a equals 10, and that's how it works. So this is like a very simple overview of the stack. Now let's quickly see it in action, shall we? So let me just move this to a different window. CD documents, tutorials, 3 CD, copy main.asm to tutorial 3 CD 3. Alright, so here we have this, right? We have the hello world code. Let me delete all of this print statements because I don't care about them. But let's show the stack in action. So let's move the value of RAX comma to 10 and move RBX comma 20 like we did earlier, right? Now let's say we add RAX comma RBX. So now what this means is, let me just write this in comments, this means RAX equals 30. Now how do I retrieve RAX's original value? One simple solution will obviously be using a third register. So move RCX comma RAX. So what this does is it moves the value 10 into RCX. So it moves whatever's in RAX, and then later I can retrieve it by getting it back to RAX. But let's say we only had these two registers, right? So let's say this was not an option. Well, I can push RAX onto the stack. So this creates the value 30 on this creates a value 10 onto the stack. And then after it's done adding, I can pop the value of RAX onto the stack. So over here I do whatever I want with RAX being 30, and then over here I pop RAX, and RAX should be 10 again, right? So let me quickly move RDI comma RAX. Alright, let us see how this works. So now when we run this, the exit code should be 10 because we pushed RAX when it was 10, and then we popped it, so we took the top value on the stack and put it back to RAX at the very end. So what should happen, and then we later move RDI to RAX, so it exits with the code that was in RAX, which is 10. So it should exit with code 10. Let's see if it works. So let me exit it and save it. Let me compile it. And echo dollars question mark. So echo dollar question mark. And will you look at that? 10. So what does that 10 mean? That means indeed that the push and pop worked. So it pushed the value 10 onto the stack, it popped it, and it basically allowed you to save those values for a later date. However, let's check something out. Let's say we push the value 10 onto this, let's say we push the value 20 onto that afterwards. Now in order to access this original value, we'll have to pop it 2 times because RAX is at the bottom, or whatever, 10 is at the bottom of the stack, and 20 is the new topmost value. So we'll have to, so if we just do pop RAX now, this will return 20 because that is the top value, right? Since that's the last thing we did, we pushed 20 onto the stack, that's the last value on the stack, that's the top value on the stack. So if we want to get back to the 10, we can do pop RAX again and get back, and then we finally, now this is returning 10 because we popped it 2 times, right? Because it removed the top value already, and there it is. However, so if we run this, we should in fact get 20, so we can confirm this. /main echo dollar question mark, and we get 20. Will you look at that? So it only accesses the top value on the stack. Alright, that's the basic overview of the stack, and I'll see you next time. Thank you.